from, sorry about that, from the Central Marine Sanitation Energy, and is the Technical Services Manager, and as well Kua Valerie, the Manager of Regulatory and Reporting at MCE, and they two will be our panelists for today. Before we jump right in, would also like to launch a poll so that we can understand the diverse nature of the participants who are part of this event today. So please go ahead and fill in what sector or area that best suits where your industry is in or where you're joining us from. Thank you for filling that out. And as we can see, we have members from the local government, water and sanitation, in the utility space, and also the developer space. So this should serve for good discussion. So as we continue, as many of you are aware, the clean energy space is changing and rapidly so. And also as part of that, we are looking at other ways of which MCE can continue to supply and provide clean energy beyond solar and wind. And as part of that endeavor, we do have multiple ways, innovative ways that we have been looking at it. And we have a couple of panelists who are going to be speaking about energy efficiency as an energy resource, and also gas to energy. And another one that I would like to point out before we go ahead is how we are also using geothermal energy as part of innovative ways at which we are attacking the clean energy goals. And part of the reason why geothermal is very important in the renewable energy space is because it offers 24/7 round the clock energy at a very high capacity factor, meaning that it's very reliable, and also you get about 87 to 90% of the megawatts that you purchase up front on the hour by the hour. The other part of it is that it doesn't take as much space for a lot of the capacity that it produces. And so the good thing about it is that in a more compact space, you'll be able to use or produce a lot more power. This is not to say that they're easily available, given that there's very specific areas for which geothermal can and will be able to be extracted to be used. And as such, as you are aware, we have to look at the various different ways to pair up the geothermal with other means to bake the entire pie of the MCE's clean energy portfolio. Now, I could go a lot deeper into how we are doing that, but for today, I would like to give as much time for our panelists to go deeper into the specific topics that they have prepared for us. And to begin with, I would like to introduce Core Valerie. who's the manager of regulatory and reporting, to talk to us about energy efficiency as a resource. Go ahead, take it away.
Thanks, Johnny. Hi, everyone. My name is Quay Valerie, and I've been with MCE for about 5 years. I'm the manager of regulatory and reporting on the customer programs team. And essentially, I oversee the regulatory filings, the reporting requirements, and compliance activities associated with our non-MCE funded programs. And yeah, today I'm here to talk about the importance of energy efficiency as a resource. I'll be using the term or the acronym EE to for energy efficiency. So just if you hear EE, that's what I'm referring to. Ashley, can you pull up the presentation? Awesome. And next slide, please. So for today, I highlight the regulatory background in California and the role of integrated resource planning. I then go into the dual aspect of energy efficiency and procurement, the evolution of energy efficiency from a mere demand reduction tool to a comprehensive strategy for grid reliability and decarbonization. And then I wrap it up with recent achievements by MCE in the EEE space. Next slide, please. So I wanted to start with SB 350, also known as the Clean Energy and Pollution Reduction Act. And this bill established clean energy, clean air, and greenhouse gas reduction goals in 2015. And I wanted to resurface this because one, this is a very popular bill in the energy efficiency space, but I also wanted to just touch on the integrated resource planning component of that bill, because in order to meet these goals, the California Public Utilities Commission, or the CPUC, was directed to establish a process for utilities to develop and submit integrated resource plans. Next slide, please. So what is the integrated resource planning and what that consists of? It's a comprehensive and strategic process that utilities use to ensure a reliable and cost-effective supply of electricity, gas, or other forms of energy while considering environmental and regulatory factors. So each utility's integrated resource plan includes an optimized resource portfolio to address the overall system needs, local reliability needs, and to ensure that the resource portfolio is flexible. Next slide, please. So when the utilities are thinking about this optimized resource portfolio in the integrated resource plan to meet energy demand and grid needs, this is a little bit of an oversimplification, but a utility really has only two options. Either they reduce energy demand via energy efficiency practices, or they procure more energy. So while energy efficiency and energy procurement are distinct concepts, they are often considered two sides of the same coin because they both contribute to achieving a more sustainable and cost-effective energy system. And by addressing both aspects, utilities can optimize that resource portfolio for the energy usage for their service area and procurement practices. Next slide, please. And here's just a main takeaway to summarize those previous slides, which is energy efficiency reduces demand and therefore reduces the need for a utility to procure additional energy resources, which often comes at a higher price, the procurement of additional resources. Next slide. So with integrated resource planning in mind and how EE plays a role in that planning process, I wanted to talk about how EE has changed over time. Prior to SB 350, EE was primarily thought of as just a tool to reduce energy demand cost effectively. And that's still the case to this day. We still think of it in that way, but it has evolved into so much more. And I wanted to give a few examples of that. So the first thing is grid reliability. EE reduces the overall demand on the power grid by using energy more efficiently, excuse me. And so therefore the needs to generate and transmit that energy is reduced, and there's less strain on the infrastructure and transmission lines. And during peak demand periods, such as hot summer days, when everyone's using their ACs, the grid can become overloaded. And it's when the energy efficient appliances that homeowners and buildings have, that's what's reducing that peak demand at that point in time to prevent blackouts and brownouts. Another aspect is resiliency. And when we're saying resiliency here, we're referring to the grid's ability to recover quickly from disturbances. So EE helps in decentralizing that energy demand, making the grid less vulnerable to single points of failure. So after a natural disaster or a public safety power shutoff event, areas with more energy efficient buildings and infrastructure can recover faster because they require less energy to operate. So it really allows for a smoother and quicker restoration of power. And then moving on to energy security, again, as I mentioned, EE reduces the total amount of energy we need to produce or import. So it makes the US less dependent on foreign energy sources and more resilient to supply disruptions. And if there was a disruption, in oil or gas due to geopolitical reasons, we can maintain operations for a longer period of time without facing significant energy shortages. And lastly, I want to talk about renewable compatibility. We're seeing the energy landscape evolve towards greater reliance on renewable sources, and EE just becomes even more critical because EE smooths out the demand curve, making it easier to integrate with those renewable energy resources, which are often intermittent. So with a reduced and more predictable demand, renewables like solar, wind, geothermal can meet a larger percentage of the grid's needs. Yeah, can you move to the next slide, please? So basically, to summarize, EE has evolved beyond its conventional role and is a vital tool for decarbonization and serves as the backbone in balancing the evolution of the grid. Next slide, please. And yeah, I will wrap up here by highlighting two recent achievements of EE. From our 2022 EE portfolio, we were able to avoid $4.5 million or so in system-wide energy costs, which we're very proud of, and we look forward to improving that number as we expand our EE portfolio budget and programs with about $20 million or so per year over the next 8 years. And I believe that is all for me. Thank you.
Thank you, Kwe, for that very informative presentation and all the work that you do to make MCE successful. So at this point, we'll be moving on forward to our next panelist, Peter Kistenmacher, who's the Technical Services Manager at Central Marine Sanitation Agency, and will be speaking to us about gas to energy project. Peter, the floor is yours.
Great, thank you, Johnny, and hello, everybody. Good to be here. I'm Peter Kistenmacher. I've been with Central Marin for about 5 years, and I'm going to share a little bit about our organic waste and power delivery program. Next slide, please. So I'll go over, who we are, what we do, and the background on our program, some of the benefits that we see for doing this. And then some of the specifics on our food to energy partnership with Marine Sanitary Service. And then I'll talk about how we make renewable power and how we deliver it out to MCE and some of our plans for the future. Next slide, please. Next one. So if you're not familiar with CMSA or Central Marin Sanitation Agency, we're a regional wastewater treatment facility in Central Marin. So we're located in San Rafael, right at the very end of Anderson Drive there. You see it on the right-hand side. That's 580 on the other side of us, and Sir Francis Drake sort of at the bottom. So very close to the base of the Richmond Bridge. We serve about 110,000 people in our service area, as well as the San Quentin State Prison. Some of the cities are San Rafael, the Ross Valley, Corte Madera, Larkspur, all of that entire area flows to our treatment plant. We have a total of 47 employees, across finance, engineering, operations, maintenance. We have a full service environmental laboratory, and then regulatory and administration staff. The core of our activities is wastewater treatment. So it's sort of everything you see in that picture on the right-hand side. And that includes the renewable power generation complex. And we do a little bit of pump station maintenance on a contract basis for smaller entities. And then we produce a relatively small amount of recycled water as well. Next slide, please. So the basics of organic waste to energy, it's quite simple. We start on the left-hand side with the organic waste, which is food scraps, discarded food waste, as well as what we call FOG, fats, oils, and greases. So these are liquids that are pumped out of like a McDonald's or a restaurant that separately collects the grease. They put those in tanker trucks and they arrive at our facility. And then, of course, we also process the wastewater solids that come down the pipe. And the core of the process for us is called anaerobic digestion. It's probably a 100-year-old technology. It's well established, and it just mixes all those feedstocks together, goes through a process and produces something called biogas. Another name for it is renewable natural gas. It has a high methane content. It's good energy value. It is for your background. It's more contaminated and less energy dense than natural gas. It has about half of the BTU per cubic foot and a lot more contaminants, but it is still a good fuel source that we can turn into energy. Next slide, please. This is more of a schematic of the bigger picture. So everything starts on the left-hand side here with the collection of the organic waste. This is an activity that our partner completes, Marine Sanitary. The food is collected in these bins. It is put onto trucks and it is brought to their transfer station, which is that second area on the bottom left. We are very fortunate that Marine Sanitary Services has a transfer station about half a mile up the road from us. So that is a key component of our partnership. They process the material a little bit further and remove contaminants, which is a very important point. Then it gets trucked to us and injected into our anaerobic digesters along with the wastewater solids. it spends about 40 to 50 days in there in the dark in the absence of oxygen, and these naturally occurring bacteria produce the renewable natural gas. We then have an engine generator, internal combustion technology, that produces power as well as heat. So we, at this time, I'm happy to say we produce about 100% of our own power needs, as well as 100% of our own heating needs. And certain times of the week, we're able to sell excess power into the grid under an existing agreement with MCE. Next slide, please. So why are we doing this? We think there's a lot of benefits to this. Some of them include that we're making our own power. In general, a wastewater treatment plant is one of the largest, if not the largest, power consumer in a community. We have lots of processes going on here, big pumps, blowers, and the like, and we just use a large amount of power. And if we had to purchase that power off the grid, it would be, several $1 million a year in power costs. So the ability to make our own power is great from a financial perspective. The ability to potentially make a little bit of revenue from the sale is interesting. And it's also more efficient because we don't have to buy power, say from solar power in the Central Valley or somewhere far away that has to be transmitted to us, and then you deal with the losses along the way. So we make the power, we use it right here, and we sell it to the local community into the grid. The other key aspect here is the organic waste, and that is a complex topic, and it's really coming from the solid waste sector. So traditionally, we, the wastewater treatment plants, have not interacted much with the solid waste sector. Those lines are coming together more and more, and the solid waste sector is being driven by Cal Recycle, which is the state governing body. And there's just a huge amount of effort over the last 10 years or so to take organic materials out of the landfill. And across the state, that is millions and millions of tons eventually that, if Cal Recycle, follows through, need to come out of the landfill and need to go somewhere else. And there's a limited number of options for that. Composting is one, and then anaerobic digestion is sort of the other big one. And by partnering with the solid waste sector, we're able to sort of help that industry comply with these upcoming regulations. Additionally, we have a lot of unused capacity, especially in our digesters. I think there was a recent study by the water boards or some wastewater organization that concluded that the wastewater sector across the state has, I forget, 70 or 80% of the capacity needed to take those organics that need to come out of the landfill. And part of the reason for us, for example, is the digesters were built in the 1980s when we still had a lot of canneries and food processing facilities in the core Bay Area. And so they're sort of oversized, and population growth, like in Marin County, is really not that significant. So we're left with this asset that has a lot of extra capacity, and we can fill that with the food waste and really do not have to pay for constructing a new digester. On a related note, we also have a lot of human capital, people like myself or our operations staff, our laboratory staff. We have skilled engine mechanics. Those folks are here anyway, whether or not we take food waste, and they're processing wastewater sludge and biogas. So the incremental cost to accept some food waste and produce more energy, more biogas, from a staffing perspective, isn't really that large as compared to somebody building a brand new digester, somewhere else. I think there's a lot of greenhouse gas benefits, across the region. You're not sending big trucks of food waste to landfills that are far away. And as I mentioned earlier, it really helps us be energy self-sufficient. And then any extra energy we can deliver to the grid, to MCE. Next slide, please. So it's called waste to energy, and the waste part is really important because you can do the next slide. Thank you. Without waste, you can't make the energy, and so there's a lot of effort that goes into finding a reliable source of waste. These facilities cost money to build and to operate, and if you have waste that comes one day and it's not there the next day, that really doesn't work from an economics perspective. So you need a long-term supply of the waste coming in. Now, we're very fortunate, as I mentioned, we have this partnership with a public-private partnership with Marin Sanitary Service. Their facility is right down the road. Their service area, as you can see here on the left-hand side, pretty much almost identical to ours, a little bit larger. And it's just been a fantastic partnership for over 10 years with them. Their goals align with our goals. And this allows us to have a predictable supply of waste coming into the facility. I think when I think through, other facilities across the states that may be trying to do this, if you do not have the supply of waste, it's going to be tough. And if it's infrequent or unreliable, it's going to be tough because you just can't produce that power on a reliable basis. Next slide, please. So I won't go much into this other than to say you need the waste, and you need the waste to be clean, because anaerobic digesters, they're a little bit finicky. And if you get a lot of contaminants, plastics, metal, pieces of bone, or whatever else is part of food waste, then your digesters can get upset, and you potentially even, you have to take them out of service, and then you cannot be accepting waste, you cannot be producing power. So Marin Sanitary spends a large amount of effort on educating their customers, teaching them how to keep contaminants out of the food waste. They have over 218 accounts at the moment, and they're planning to expand that over the next years. Next slide, please. Next one, please. All right. Next one. You can keep clicking. These are just some pictures to share with you the effort that goes into training kitchen staff to properly separate the contaminants from the food waste. Next slide. So this is a picture of what we currently get from Marin Sanitary Service. Very high quality, but small quantity. So the trade-off being, if you want to expand your quantity, your quality goes down. And what happens then, next slide, please, is you have to put in an engineered solution. You have to put in these equipment pieces at the transfer station that take out the contamination. Marin Sanitary just invested in this particular unit here. It's called a Tiger depackager. It's working really well. It produces a clean feedstock at the end, and all the contaminants stay on their site. Next slide, please. So then we go to CMSA. This is our receiving station. Next slide. Here you see a picture of the truck offloading the food waste. Next slide, please. Here you see a picture of the fog, the fats, oils, and liquids coming in a tanker truck, and we mix those things together so they become sort of pumpable, and we can inject them into the digester. Next slide. These are the digesters and the gas cleaning equipment. Next slide. And then here's our power generation unit. The top right, the green unit, that's the heart of our power plant. That produces up to 1 megawatt of green energy. On a typical day, we use about 600 kW, and that leaves the rest of it, say 400 kW, for sale into the grid, into MCE, if we have enough biogas. And now what we're spending a lot of time on is getting more feedstocks into our facilities so we can have more biogas to sell into the grid. Next slide, please. Next, please. I'll just briefly touch on this, but there's a ton of electrical engineering that goes into making all this work. Relays, PG&E interconnection. This took several years to work through, and it's quite expensive, but it is working now, and it's working great. And just something, as you think through doing that yourself, you will have to invest into upgrading your electrical infrastructure to allow power to flow both ways, into your facility and out to the grid. Next slide, please. And just wrapping it up, I think what we're also fortunate to have is this 10-year power purchase agreement with MCE, where they're agreeing to purchase any extra power that we make. They're paying us currently about 8.5 cents a kilowatt hour for that power. It's a very nice agreement in terms it has a lot of flexibility for us. There are no minimum delivery requirements or no firm commitments, and the invoicing part of it and getting paid is working, seamlessly. It's been a really great experience. Next slide. So I think I'm out of time, but this is just to give you a sense of that none of this happened overnight. We're really looking at least 10 years of sequential work that happened, starting with constructing infrastructure, entering and negotiating agreements with PG&E, with MCE, with the feedstock suppliers. We did a lot of studies to help us optimize the system. And just recently, we won a $2.5 million grant from Cal Recycle to expand the facility. So we're sort of looking out, how can we expand this? How can we bring in more material? How can we produce more power that we can sell to MCE? I think I'll wrap it up there.
Thank you, Peter, for that very informative and educative presentation. So at this point, I know our members do have questions, and what we have done is we're creating breakout rooms, and each of the 2 breakout rooms are gonna have our 2 panelists. One breakout room is gonna have Quay, the other breakout room will have Peter, and then MCE staff, including myself, will be in the main room. You're free to join either one of these break rooms to ask any follow-up questions you may have for our panelists. And the icon for joining the breakout room should be at the mid bottom place on your screen, right next to the show captions button.